All right, we're going to go over the problems I gave you guys in class. These problems are from a math packet from the ACT people. They used to put out a test called the ACT Compass, which was for students who are already in the university but need placement. And they don't make that test anymore. I think it was phased out 2016, 2017. At any rate, the problem's are very similar to what you encounter on the ACT. And this particular packet I like a lot. This is from the 2014 ACT Compass test. So you should be able to find that online. Of course, if you're in my class, you already have it. All right, so let's take a look-see. Number 1, what is the next term in the geometric sequence 16 minus 4, 1, minus 1, 4? Well, a geometric sequence is a sequence of numbers where the next number is a result of multiplying the previous number by some constant value, as opposed to an arithmetic sequence where the next value comes by adding a constant value. So we just need to figure out what they're multiplying each of the numbers by to get the next one in the sequence. So if we look at 16 and minus 4, okay, it's pretty clear they're dividing by 4, aren't they? In fact, they're dividing by negative 4, because 16 times negative 4, or if you will, divided by negative 4, 16 times negative 1/4 equals minus 4. And minus 4 times negative 1/4 equals, well, 1. So there we are. And then 1 times minus 1/4. So the next number should be the last term there, minus 1/4, times minus 1/4, which is a positive 1/16. And there we go, C. Now, I don't recommend you guys do your math in pen like I'm doing here, but I wanted to show up nice on the video. Yeah, so there's that. All right, number 2. A manufacturing company processes raw ore. The number of tons of refined material the company can produce during T days using process A is A of T equals T squared plus 2T, and using process B is B of T equals 10T. The company has only 7 days to produce ore and must choose one of the processes. What is the maximum output of refined material in tons for this time period? Well, in either case, 7 is our T, is our time. So we just need to find out what A of 7 is and compare that to B of 7 and see how it looks. So let's start with A of 7. So A of 7. If 7 is T and A is equal to T squared plus 2T, then this is just 7 squared plus 2 times 7. Well, 7 squared is 49, and 2 times 7 is 14. 49 plus 14, of course, equals 63. All right, well, there's one of my answer choices, D. Maybe that's right. Well, let's find out what B of T equals. Well, B of T for 7 is 10 times 7. 10 times 7 is 70. So clearly, B of T will give me the maximum output. So the answer will be E70. If it looks like I've got 2 different hands, that's because this hand is rather swollen. And it's really quite painful. Okay, enough about that. All right, what do we got here? All right, number 3. For the 2 functions f of x and g of x, tables of values are shown below. What is the value of g of f of 3? Okay, so a function is just some statement of some kind that if I plug in a number for x, I get some other number f of x as a result. Okay, well, we have our tables that tell us. So this says if I put in minus 5 into f, it returns a 7. If I put in a minus 2, it returns a minus 5. And likewise with g, if I put in a minus 2, I get a 3. If I put in a 1 for x, I get a minus 1. Okay, so they're asking for g of f of 3. So in order for me to find out what number I need to plug in for g, I first need to figure out what f of 3 is. So I go here to my table of f values, and I look at x, I go down to 3, and I see that f of 3, if I plug in a 3, it gives me back a 2. Good. So f of 3 equals 2. So if I'm trying to find g of f of 3, what I'm trying to find is g of 2, because f of 3 equals 2. So I go over to my g table, I go down till I see 2, I move over, ooh, minus 3. Looky there. So the answer would be B. Bravo. Excellent. Okay. Problem 4. For positive real numbers x, y, and z, which of the following expressions is equivalent to x to the 1/2, y to the 2/3, z to the 5/6? Well, you may recall that if I have some value, let's say x, to some fractional exponent, a over b, that is equivalent to the b root of x to the a. For instance, if I had 4 to the 3/2, that is equal to the square root of 4 cubed. 4 cubed is 64, the square root of 64 is 8. So whatever is in the denominator, that's my root. Whatever's in the numerator goes under the radical as an exponent on the value. Okay? So that being said, let's return our attention to this. I have x to the 1/2, y to the 2/3, z to the 5/6. Well, in order for me to combine these into one thing, I need to have them all have the same denominator so that they all have the same root. Okay, and that's easy enough. X to the 1/2, I can write as x to the 3/6, means the same thing. Y to the 2/3, I can write as y to the 4/6. Multiply top and bottom by 2. And z already has a denominator of 6, so I'll just leave that alone. 5/6. Now using this method here then, this rule, that means I have a root of 6, and underneath that I have x to the 3rd, y to the 4th, and z to the 5th. X to the 3rd, y to the 4th, z to the 5th. Answer D. There you go. Easy peasy lemon squeezy. Number 5. If A is the matrix 2 minus 4, 6, 0, and B is the matrix minus 2, 4, minus 6, 0, then A minus B equals what? Well, when you're adding or subtracting matrices, you just compare them element by element. So we're subtracting, so my new matrix will be A minus B. So 2 minus a minus 2, that's 2 plus 2, or 4. Minus 4 minus 4 is minus 8. And 6 minus a minus 6 is a positive 12. And 0 minus 0 is a 0. So my matrix A minus B should be 4 minus 8, 12, 0. 4 minus 8, 12, 0. Answer E. Lovely. Lovely. Okay, number 6. Listed below are 5 functions, each denoted g of x, and each involving a real number constant, c greater than 1. If f of x is 2 to the x, which of these 5 functions yields the greatest value for f of g of x for all x greater than 1? Now that seems all pretty complicated and mathy, but it's really not. We know that f of x is 2 to the x. So f of g of x is just whatever g of x is, something to x. So the statement A, if g of x is cx, that's just 2 to the cx. For b, it would just be 2 to the c over x, and so on and so forth. So what you've got to ask yourself then is, which of these g of x's is largest? Because whichever one of these is largest, that means I'm taking 2 to the largest number, and that will give me the greatest value. So I just need to figure out which one of these is largest. And it matters a great deal that we know that c and x are both greater than 1. So that means c times x has to be greater than both c and x, because c and x are greater than 1. You multiply something by a number greater than 1, you get a number greater than you started with. So c and x are both larger than c and x. That's a larger number than we started with in either case. Similarly, c over x, okay, whatever c is, we're dividing it by some value x. So it can't be as large as c times x, again, because c and x are greater than 1. So that is not, a is certainly larger than b. Similarly, x over c, we're dividing x by whatever c is. So it really doesn't matter what the values for c and x are. C is certainly not greater than c times x. And obviously, if we subtract, that's certainly not greater than c times x. And the log base c of x means what number do I raise c to get x? Well, it's certainly not larger than x. So answer A. Cx is the largest of those combinations if c and x are both greater than 1. That's crucial. Yes. Okay, answer A. Number 7. If the function f satisfies the equation f of x plus y equals f of x plus f of y for every pair of real numbers x and y, what are the possible values of f of 0? Okay, well, f of 0 means that I would have to have something, I'm just plugging a couple real numbers in here. That means I would have, say, minus 3 and 3. So x and y are minus 3 and plus 3. Excuse me. That would give me my f of 0. And if f of x plus y equals f of x plus f of y, okay, then that means that this must f of x minus 3 plus f of positive 3 in this example must equal f of 0. So what are the possible values of 0? Well, we know that f of 0 is 0. So the only possible value for f of 0 is indeed 0. I don't know if I explained that very well. Let me think. F of 0. 0 only. Not really good on my explanation there, but how can I explain it differently? He wondered aloud. There's just no way around it. You know, that's f of 0, and it's a result of f of 3 and f of y, and if x and y are the result of 0, answer can only be 0. If I think of something real clever to make that clear, I'll bring it up. Okay, the imaginary number I is defined such that I squared equals minus 1. What does I plus I squared plus I cubed plus I blah, blah, I to the 23rd equal? Okay, so let's look at this here. So we have the number I. And we have the number, we're going to square that, so this will be I squared. Then we're going to multiply or add I cubed to that. And then we're going to add I to the 4th, and I'll go one more here, I to the 5th. Okay, so I is already defined. That's just I. Now, I squared is minus 1. So now I have I plus I squared, which is I plus minus 1. So I cubed will be I squared times I, which is I times minus 1, which is minus I. Look at that. And I to the 4th is I squared times I squared, which is minus 1 times minus 1, which is plus 1. So you can see here in the first 4 terms, I've got a positive I and a minus I. They cancel out. I have a 1, positive 1, and a minus 1. They cancel out. So the first 4 terms sum up to 0. And you can see that's going to happen over and over and over again, because I to the fifth is just I to the fourth times I, which is just 1 times I, which is just I. So I just repeat these same 4 values, I minus 1 minus I and positive 1, over and over and over again. So if the result were a multiple of 4, I know my answer is 0. It's not. So we need to consider the last 3 terms. So we know that if we got to I to the 20th, that up until then, everything's 0. So we're only interested in the last 3 terms, which are I to the 21, I to the 22, and I to the 23. So we know that by the time we get to a multiple of 4, this is 1, and the sum up till then is 0. So I'm just interested in the sum of these last 3. Well, I to the 21st is just I, because if I divide 21 by 4, I get a remainder of 1, so that's the same as I to the 1, or I. Similarly, if I divide 22 by 4, that's I, the same value as I squared, so that's going to be a plus, a minus 1, and then I to the 23rd is the same as I cubed, which is minus I. So we're just missing that I to the 24th term, which would put me back to 0, but instead my positive I and my minus I cancel out. So the only value I've left is minus 1, answer C. There we go. Yeah. Any problems you encounter dealing with I's on the ACT are almost certainly going to be involved with the fact that that's cyclical, that every time you reach a power of I that's a multiple of 4, it just repeats over and over and over again. So keep that in mind. All right. In an arithmetic series, the terms of the series are equally spread out. For example, in 1, 5, 9, 13 plus 17, consecutive terms are 4 apart. If the first term in an arithmetic series is 3, and the last term is 136, and the sum is 1,390, what are the first 3 terms? I'm sure I have no idea. Or do I? Let's look at an arithmetic series in general. Let's look at a simple one. Let's say I wanted to add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. I want to add up those numbers right there. So I could get my calculator, I can go 1, 1, 2, 1, forget that. What we can do is we look at the first term and the last term, 1 and 10. Well, 1 plus 10 is 11. If we look at the second to last term, 2, the second term rather, and the second to last term, 2 and 9, 2 plus 9 is 11. If we look at the third term and the third to last term, 3 plus 8 is 11. Look at that, wouldn't you? All right, and if we looked at the fourth term and the fourth to the last term, 4 plus 7 is 11. And in here, the fifth term and the fifth to the last term, 5 plus 6 is 11, for a grand total of 55. So we can generalize that. What we're saying is that if you give me an arithmetic sequence and I know the first term and the last term, and I know how many terms I have, I can figure out the sum, because the sum will simply be the number of terms I have, which in this case is 10, times the first term plus the last term, which is 1 plus 10. And then because I'm pairing those up, I have to take the number of terms I have, which is 10, but I get 5 pairs, or 10 divided by 2. So 10 over 2 is 5 times 1 plus 10, 11, which is 55, which you already knew. Now there's a formula here. The general formula says the number of terms plus a sub 1, which is your first term, plus a sub n, which is your last term, divided by 2 is the sum of an arithmetic series. Okay? But even if you don't know that, if you can understand this idea that if we keep taking successive first and last term, second to last term, we're going to add those together and get the same number. So we just need to know how many of those pairs we have, bada bing, we're done. Now in this example, we know the first term, we know the last term, we know the sum. What we don't know is the number of terms, okay? But we know this, we know that whatever the number of terms is, let's call it n, if I multiply that by the first term, which is 3, plus the last term, which is 136, and divided that by 2, that should equal my sum, which we know is 1,390. Okay, excellent. All right, well that means this is 3 plus 136 is 139 times n over 2 equals 1,390. Multiplied by 2, so now I know that 139n equals 2,000, well that's 180, 2,780. And if I divide n into 2, well, we know how much that is because that was 10. It's just going to be 20. So it looks like n is 20. So that's the number of terms I have. Now, be careful, because what this means is that if I have 20 terms, that means I don't have 20 spaces, I only have 19 spaces. In other words, if we look at this exchange here, I have 10 terms, but only 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces between my terms. And it's that spacing that will determine how much we're adding each time to get to the next number. So I want to take this 136 plus 3. That's my last term. Okay, so I've covered, how far have I covered from 136 to 133? That'll be 136 minus 3. I've covered a range of 133, and I've done it in 19 steps. Yes. So once again, we know our first term and the last term, we've covered a distance of 133. And it didn't take us 20 steps. It was 20 values, 20 terms, and there's 19 spaces. We're interested in the spaces between the terms. There's 19 spaces. So 133 divided by 19, well, 7 times 20 is 140. So this would be 7 because we're subtracting one value of 7. So this is going to be 7. So 7 then is the value between all my terms. So if my first term is 3, my next term will be 3 plus 7, which is 10, and 10 plus 7, which is 17. So answer A. There we go. That one's kind of tricky. You got to understand how arithmetic series works. How arithmetic series work. Sorry about that. And so we've got to plug in our known values, figure out how many terms we had, consider that that is one more than the spaces between the terms, and then back it up so I could figure out exactly how much I'm adding to go from term to term to term. And there we go. Excellent. Superb. All right, let's move on to some trigonometry questions. In the right triangle shown below, the length of AB is 8 units. Angle A measures 60 degrees. The sine of 60 is 0.866. The cosine of 60 is 0.5. And the tangent of 60 is 1.73. Okay. Approximately how many units long is BC to the nearest hundredth of a unit? Okay. Well, there's a few ways we could do that. But what I want you all to recognize, because this comes up again and again and again, we talked about our 3 special triangles. And one of those special triangles that shows up over and over and over again is the triangle that has 60, 30, and 90 degrees. And we know that such a triangle is always in the following ratio, 2, 1, root 3. So here we know if this distance AB, which hypotenuse is in this ratio, if that's 8, then this is half of 8, which is 4. And that means the distance BC is 4 times root 3. 4 times root 3. So there's my answer, 4 times root 3. Whoa, that's not in here. So what the heck is 4 times root 3? Well, root 3 is about 1.7. So 4 times 17 should be a little more than 64. So yes, it's going to be D. So answer D. Yeah, 4 root 3 is 6.928. Yeah, answer D. Answer D. Now, if you didn't recognize that that was that special triangle and just went off the ratios that we know, but you should because that shows up over and over again, I want to stress that, then we could have found it using the material they've given us up here. You want to know what that distance is right there. Well, what we can say is that the cosine of 60 is, sorry, that's 4 over 8. The sine of 60, that's what I want. The sine of 60, you will recall SOHCOATOA. Sine is opposite over hypotenuse, cosine opposite over adjacent, tangent opposite over adjacent. So sine is opposite over hypotenuse. So if we're looking at 60 degrees, the opposite is BC, which is what we want, and the hypotenuse is 8. So we could say that the sine of 60 degrees is equal to BC over 8. That means BC is equal to 8 times the sine of 60 degrees. They told us 60 degrees, 0.866. So 8 times 0.866, 86% of 8. Again, we're pointing right at D. So you could have done it that way as well. But look for those special triangles. They show up over and over and over again. Number 2. If the sine of alpha is 12/13 and the cosine of it is 5/13, then alpha is, okay, well, let's just work it out here. This is not going to be drawn to very good scale, but nonetheless, there's my alpha. Sine is opposite over hypotenuse, so that means the sine of alpha is opposite 12 over hypotenuse 13. The cosine of alpha is adjacent over hypotenuse, so that's 5 over 13. All right. So the tangent of alpha is opposite over adjacent, so 12 over 5. It looks like answer C. Look at there, slick as you please. Good old trigonometry. You gotta love it. Okay. Now, it's 0. If x is between 0 and 90 degrees, and the sine of x is 1/2, and the cosine of x is what? Oh my goodness. Okay. Well, this information here is important because that tells us what quadrant we're in. So what we're saying is that we're in the first quadrant because there's 0 and there's 90 degrees. And I have some angle, call it x. And I know that the sine of x is opposite over hypotenuse is 1 over 2. Well, by golly, if that's not, again, our special triangle, you could also use Pythagoras' theorem to figure this out. But we know that this is root 3, because even though they don't tell us, we know that's a 30/60 because of the length of the side. So there's our special triangle again. It pops up again. So the cosine is just opposite, adjacent over hypotenuse, which is root 3 over 2. Answer B. Okay, look at that. From a hot air balloon, the angle between a radio antenna straight below and the base of the library downtown is 57 degrees, as shown below. If the distance between the radio antenna and the library is 1.3 miles, how many miles high is the balloon? Okay, so we have this angle here, and we know what the distance is opposite that angle. We're trying to find the distance adjacent to that angle. That looks like tangent to me. So we can say that the tangent of 57 degrees, there it is equal to the opposite, which is 1.3, over the adjacent, which is our question mark. So if I do a little algebra here, multiply by the question mark, then divide by tangent 57. That means my question mark is equal to 1.3 divided by the tangent of 57 degrees. And I don't need to work that out because that's the form my answer's in. 1.3 divided by tangent 57 looks like that's going to be answer C. Okay. 5. What is the smallest positive value for x where y equals sine 2x reaches its maximum? Okay, if you haven't had trigonometry formally and you're taking the ACT, a problem like this is going to be pretty hard for you. But you've got to understand when I have the function y equals sine x and I put a value in there, how does that affect sine? Well, sine looks like this. It has a height of 1 and a trough of -1. It starts at 0, and it has important values at pi over 2, pi, 3 pi over 2, and 2 pi. And starting from here, it goes up to 1 at pi over 2. It crosses down to 0 at pi. It goes down to -1 at 3 pi over 2. And it goes back to 2. And then it just keeps going. But either direction. Just does that over and over and over and over and over again. So the distance that it takes before it starts to just repeat itself, that's called the period. And for sine, the period is 2 pi. When I put a coefficient in on the x, it affects that period. If the coefficient is greater than 1, it reduces the period by that factor. If the value on x is less than 1, let's say I have y equals sine, y equals sine of 1/2 x, that's actually going to double my period. So instead of going from 0 to 2 pi, it's going from 0 to 4 pi. So the sine of 2x will reduce it by a factor of everything by a factor of 2. So this value here, which is pi over 2, which is where it currently equals 1, will be reduced by a factor of 2. So pi over 2 divided by 2 is pi over 4. So that value of 1 will be scrunched over because the whole graph now will do exactly what it's doing, but it does it between 0 and pi rather than 0 and 2 pi. So answer A, pi over 4. All right. Oh, 6, this is a big one. All right, let me move that up a bit there. One of the graphs below is that of A equals A sine theta for theta between 0 and 6.28 radians, where A is a constant. Which one? Okay. Well, again, I draw you toward the notion of what does y equals sine x look like. Again, it goes from 1 to -1, and it has interesting, important values at pi over 2, pi, 3 pi over 2, and 2 pi. And from here it goes up to 1. It crosses down, goes in the... So we saw from the last problem that if you put some value in with the x, that changes a period. But if you put a value in front, like a, that just changes its height. For instance, y equals 2 sine x just means instead of going from 1 to -1, it's now going from 2 to -2. It just changes what's called the amplitude. It makes it go higher or lower by that amount. So we're looking for a graph that's, well, we don't know if a is larger than 1 or greater than 1. So it could be higher than this standard graph. It could be lower than the standard graph. But it also has to have the right points in the right place because nothing else changes. It still starts at 0 here, it crosses at 0 there, and it ends up at 0 there. Okay? So, first off, it can't be B, because B, the graph is not even where it should be. It's up there. Okay? If we look at this value here, 6.28, this is your 2 pi out here. So it looks like we've got 1, 2, 3 cycles in there. It's not C. Okay? Let's look at D. D. Nope, see, now we don't even have a full cycle between up here to 2 pi. 2 pi, 6.28. E, oh, look at that. That's not right at all. Look at that. It makes a full cycle, but it doesn't start at the right place. It should start from here and go up like that. So A is going to be our answer, and sure enough, in fact, we can declare with some certainty that A is actually 3 in this example because it goes up at 3 and -3. Nothing else changes. Starts there, crosses at 0 at pi, and finishes at 2 pi. So Answer A. All right, last one. In the right angle below, the length of AB is 13 units and the length of CB is 12 units. What is the length of angle? Oh, sorry, what is the length? What is the tangent of angle A? All right, no problem. First off, we have right triangle. That means we can apply Pythagoras' theorem. And you'll recognize when you work with right triangles, even just a little bit, that certain ones crop up, like the 3, 4, 5 triangle. That's called a Pythagorean triple. And another popular triple is 5, 12, 13. But if you don't recognize that, we'll just apply Pythagoras' theorem. 13 squared should be equal to 12 squared plus this length here. I'll just call that A. I should call it B because it's opposite B. I'll call that B plus B squared. Okay, so that's 169 equals 144 plus B squared. Subtract 144. B squared equals 25. So B equals 5. So I know this distance is 5. So there's my angle A. The tangent is opposite over adjacent. So 12 over 5. Answer A. Whew.